Now, why are we using the computation of a 2 by 2 determinant? Or maybe even a computation of a 3 by 3 determinant? Okay, let me remind you that behind every determinant, there's really a matrix here. So even for this problem here, you could see that there's a matrix A, -9, 9, -2, 5. And there's a 2 by 2 matrix multiplied by a 2 by 1 matrix will yield a what? A 2 by 1 matrix. So this system of equations can be looked upon in the format of charts, or in our specific case, something called matrices. We're going to use Cramer's rule, though, to actually try to solve this system. So instead of using matrices, or instead of using your beginning and intermediate algebra techniques that you may have learned in the past, you're going to learn more advanced techniques. And of course, why would you do that? To develop more of a efficiency and proficiency in understanding how to solve systems of linear equations. This is often called the coefficient matrix A, and this is, if in higher courses, this would just be called X bar, and then this would be equal to B bar. Don't worry about that bar. What we are going to do is state Cramer's rule. Cramer's rule goes something like this. Cramer's rule is a theorem. If you have, let's say, ax plus by is equal to, let's use g sub 1. And you have what? Cx plus dy is equal to g sub 2. And if, keyword is and, you need the determinant called d. D is going to be this. A, B, C, D is not equal to 0. Then we could actually get x is going to be equal to G1, G2, BD, determinant of that array, over D. But what's D? D is A, B, C, D, a determinant of that array. And what? Y is equal to A, C, G1, G2 over A, B, C, D. And you can see why this is a major requirement right here. The denominator cannot be what? Cannot be 0. Okay, the denominator cannot be 0. And of course, I need to finish the theorem with a period. Now, keep in mind there's a big comma here. You must satisfy the big comma before you could actually make the conclusion. Okay, so most theorems in mathematics are if-then statements. So my comma is looking really weird here. Let me fix that. Hello, comma. All right. Why don't we see if Cramer's rule works for this system here. Let's check matrix D. Let's check matrix D. What is matrix D? D is going to be -9, the array -9, 9, -2, 5 with vertical bars. And we want to evaluate this expression. Well, that's -45 plus 18. Yeah. Which is equal to what? -27. Now, what's so special about -27? It's not equal to 0. Okay, that's a really key step. Because what you're really doing there is stating that the denominator is not going to be 0. The denominator is not going to be 0. What does this mean? Therefore, Cramer's rule applies. And so if Cramer's rule applies, we can actually write x. X is simply going to be 8, negative 7, and 9, 5, and then over d. And we already know d is non-zero, so that's really, really key. 45 plus 63. What's 45? I mean, not 45. What's 40 plus 63? 40 plus 63 is 103. Divided by what? Negative 27. What's y? Y is going to be negative 9, negative 2. And then we have 8, negative 7. And put this over d. Now remember, this is according to Cramer's rule. And how do you prove Cramer's rule? You would once again have to take a course called linear algebra. It's quite sophisticated, but it is proven much later in a course much higher than this one. Let's figure out what y is. Y is going to be 63 plus 16. 63 plus 16 is 79. And put that over what? Negative 27. Now, 103 is not divisible by 3 or divisible by 9. I don't think it's divisible by 27 either. No, it's not. No, it's not divisible by 27. So this is actually done. These are actually reduced fractions. 79 is a prime number, and then negative 27 doesn't matter. 79 is a prime number. So we know that this is a reduced fraction already. So we can find our what? Our answer to our system of equations. Just like that, you're done. In this case, it's a set consisting of a unique solution. Singular here. It's not plural, it's singular. So this is a set consisting of a unique solution. Geometrically, remember that these two actually graph what? These two equations graph a straight line. So how do straight lines intersect? I mean, if they do intersect, they could intersect at a single ordered pair. But for now, remember this as a set consisting a unique solution.